Good afternoon, everyone. This, as you can see, is the Python and Oracle database session. Most welcome to stay if you just want to use the room for some desk space. I'm going to make a quick start. As you'll see, I seem to have a fair amount of content to get through. Standard Oracle safe harbor statement, Python open source, the area I work in is all open source. You know, no timelines, so don't make any purchasing decisions based on anything that I do say. So, my name is Christopher Jones. I spent a number of years at Oracle. I worked out of Oracle's headquarters in Silicon Valley for nearly 10 years. I've now returned back to Australia. So it's about 4 a.m. body time for me at the moment. But I worked a long time with open source. I worked on upstream PHP, PHP Oracle database drivers. I worked out a Linux group. They were doing things like the dtrace support, things like that. So I kind of, definitely been in an open source space for a long time. I've moved into the Oracle database group, and I have a broadened focus. So I look after a lot more database access APIs. Sorry for that Australian, the A's and the I's. I hope you understand what I'm saying there. So I look after things such as Python, PHP, Node.js. I'm giving a Node.js talk later today. I also have some side responsibilities for things like the SQLnet layer, the Oracle Net layer. That comes out of my team as well. And SQL+, the good old SQL+ tool. In fact, I used to work on SQL+, but that was back in the past. So just a quick kind of refresher what the group does. The wider group looks after those things in the red and the blue. All of the database access APIs from .NET, JDBC and things. I look after mostly the sort of blue bits and pieces, and then do some liaison with the open source community for some of the other drivers down there. You can see we support a bunch of really interesting languages, Go and Rust and things like that. Support in the it works support, not the uppercase telephone support. So today, 4 quick areas that I was going to talk about. Just a little bit about the CX Oracle driver, then a little bit of a refresher for the CX Oracle version 5, and then obviously 6, and then go into some more advanced tips and tricks for people who really do want to get into the guts. So who is using CX Oracle database access layer? Yes, who's using Python at the moment? So got more Python people perhaps there. Fantastic, that's good to see. And then, so what is everybody else using? Are you doing other languages or not? Maybe not developers? Okay. So CX Oracle is the package which gives access, as you can see on the screen, to all of the features in Oracle database. It began as a third-party project. It's now under the Oracle umbrella. It has an open source license, and we're pretty active. You can see only last month we released the most recent release. It has most of the features of the DBI spec from Python, a couple of exclusions, and we have a lot of extensions there. The overall architecture, this does kind of confuse people who are not used to it. We still, in this space of all of the sort of drivers, the C language drivers, Python, Node, PHP, they all sit on top of Oracle client libraries. So you need to get those Oracle libraries on your machine somewhere. And then obviously Python speaking out to your users, reading your scripts, calling down into the CX Oracle API. And those client libraries are the things which are responsible for talking through to Oracle database. So talks as I have there, this is cloud, we've got to have the cloud slide. This is my cloud slide for today. You can see it talks through to the Oracle Cloud database or your on-premise database. So, easiest way to get those client libraries is the Oracle Instant Client. Now the benefits of having a client library there is like completely well-tested stack. Everybody uses it. Our internal tools use it. Testing groups test it. Used for a whole bunch of high availability features, connection management features, caching, network traffic support, network encryption. Has anybody enabled network encryption with the Oracle Net layer? So traditionally it's not part of the drivers, it's not part of CX Oracle, but it's just the layer beneath, so you have it available through CX Oracle as well. I'm not going to talk about that later. Nowadays we have these pre-built binaries. Young.oracle, for anybody using Oracle Linux, has some binaries out there which are really useful, the package manager. Oh, sorry, I do have one more little bit of cloudware there, just a couple of URLs if you're interested in that. Instant Client, zip install, zip install, unzip to install, or you can get RPMs on Red Hat. variants like Oracle Linux. Okay, that's it. That's the intro. Everybody's here. Let's go straight into 5. So 5.2, there's a little bit of a gap between 5.2 and 5.3. 5.2 came out in 2015. Oracle began contributing code into 5.2. That was our sort of first foray into the Python space. And then we hired Anthony, and Anthony Tuaninga is the creator and maintainer of the Oracle CX Oracle interface. So we had this huge release in 2017. That's only like less than 1 year ago, or just on 1 year ago. So it had a huge bunch of features, and I'll cover some of those today. Some of them, of course, I won't have time for. This talk is actually, this presentation is really sort of designed for an hour talk. And I should have said actually in the front is my colleague Blaine Carter, who's talked earlier today. He's talking about some Python stuff at the Oracle IOUG Collaborate conference in a couple of weeks. He's doing a hands-on lab on Python and doing a session as well, 1 week. So, yeah, this is a slightly condensed version of that talk. Apologies, contact me if you want more information. Things like transaction guard, I'm sorry, I probably won't get time to cover today. So, array DML row counts. I'm jumping right in here for people who don't know what's quite going on. Normally you can execute a statement. You can execute a SQL or PL SQL statement and get the results back. That's fine if you're sending across, doing inserts of tens of thousands of records or 10 records. You're going to be executing that statement 10 or 10,000 times. That's generally not efficient, so we recommend using this execute many method, which has been there for a while, which is why it's not on this slide. I'm speaking about the new features. The key thing with optimizing client, Python to database performance is reducing network round trips, reducing the calls, the interrupts on the database when the database server has to wake up, has to do some work for you, can't do work for anybody else, has to send messages back. So execute many reduces those round trips significantly. So example of DML is obviously an insert, update, delete, merge. And this extra feature which was added here in 5.2 lets you work out exactly how many rows were affected by each of the data values which are passed in, which I'm going to show in the next slide so don't get too worried. Need to set up the scenario a little bit. Pretty much basic parent-child relationship. We don't really care about the data for this example, but effectively you've got client IDs and parent IDs. So here we have the execute many call, so now you can actually see it in action. So we're passing in at the top there, you can see parent IDs delete. So we're passing in 3 values. So effectively we're executing that delete statement 3 times with 3 different values, 30, 20, 30, and 50, if I can read my little font here. With this extra new option, for those who've already used execute many, array DML row counts true, you can actually get back the values which were deleted for each of those IDs. Here I've obviously got some kind of fake data, assumingly that I had 3 rows which had parent ID 20, I would get this kind of data back at the bottom. So one little extra flag you can add, you can actually then power your apps and understand better what's going on when your data gets transferred to the database. Batch error, so another little option there to the execute many is that if you're trying to insert 10,000 rows, what happens if one of those rows has a dirty value? What happens if it has a string when it's supposed to be a number? 10,000 rows inserted, 10,000 rows rolled back, whoops, not so useful. Quite often you just want to insert everything you can. Maybe you can fix up that one row, maybe you don't care if you're doing some data ingestion for log analysis or something, just do best effort. The batch errors solution lets you actually solve that problem. Lets you return an individual error for an individual dirty set of data while letting the other pieces of data be inserted correctly. So here's the example. You can see up there in red, got a couple of duplicate keys, one where the parent doesn't exist. Going to do an insert there on line 9, just a straight insert into the child table. And you can see here, I didn't point it out before, but you've got 3 bind variables, and if you look at the array of data to insert, there are 3 columns. So I'm going to execute that insert for each of those records there. Each of those 1016-10 red will be bound to those 3 bind variables. And we always use bind variables. Why do we use bind variables? For performance because it means you've only got one SQL string, so that only has to be parsed once for different data values. Use it for security, because there's no data embedded with the statement. The data in the statement go across to the database separately. Very, very important. I just saw in a talk before, SQL injection issues, 46% or something of security problems use blind variables. So anyway, back to batch errors. As you were reading ahead there, I'm sure, and I'm sorry I should have fast forwarded there, we're going to get an array back of errors. So for each of those, we've got 2 errors there, 1 duplicate key, 1 parent does not exist, we get 2 values back that we can process. And there's an offset there, which is a 0-based offset. A little hard with the numbering up there, but you can kind of see that row offset 2 was the 3rd data value down there, 1018, where I've got the comment duplicate key. So this is really useful if you're going to do inserts of large values. I've forgotten now the data set that Anthony told me a couple of days back in terms of performance, but I know in this afternoon's talk I'm going to talk about execute many in the context of Node.js, and the graph is performance is way up versus just a standard execute. So execute many really is very valuable, and this kind of extra feature makes it even more useful to you. A whole bunch of other 5.2 enhancements, which I kind of really don't have a lot of time to get into. 32 kilobyte varchars and raws. You know now that we don't just have the 4K limit on data. We're starting to see, obviously, people putting pressure on us for more. I've got examples of how to work with LOBs and make LOBs really efficient as well if you want to get into that space. You need more than 32K, that's coming up later. And small features here, small features there is always better going forward. Python 3 obviously introduces Unicode by default. Is anybody using Python 3? I guess there are only a few people. Anybody still using Python 2.7? A couple, yeah. I'm kind of still stuck a little bit back, but I know they're pushing really hard to update to everybody in the Python world to 3. So straight into the 5.3 features, so I can get into those really nice advanced features. Binding of named objects. So there was support for querying named objects, things like spatial data objects you could query in old versions of CX Oracle. Now you can actually bind them, so you can take a data value and bind it for insert or fetching out of the database. And I just mentioned why binding was important. And you'll see later how you can do mapping straight into Python objects as well. So effectively you can just deal with Python objects in the Python code, bind it into Oracle and Oracle in the PL SQL, or the SQL will just be dealing directly with the Oracle object in the back end. So you don't have to do any data mapping, you don't have to write any wrapper PL SQL functionality. Okay. Let's have a look at one simple example. So this is the SDO, spatial data object, so pre-supplied object. It has some sub-objects there if you look down on the lines, 11, 12, 13, some other Oracle types down there. I'm not going to go into great details on all of those, but let's look at a straight example. So we have this new get type method. So we have to actually make a call to the database, so a round trip to the database, work out what that SDO geometry looks like, so then we can do internally in the CX Oracle, can do some internal data representation to match that. We do get type 3 times, because I mentioned it has those other subtypes. And then we just create a new object. And there I'm using new object directly, or you can just use type object with the brackets. And then set some data. Extend an array, or just set the data values directly there with the 2003. And at the very bottom, insert, and I'm just doing a straight bind into the table. So the table has a particular type with that SDO type. So that makes it really, really simple. And I saw a great demo from our spatial team recently, and I think there's some talk at this conference. A lot of Python happening in the spatial world, and they were very excited, this team very excited that they've just discovered CX Oracle for some reason, and they were doing demonstrations of putting Python CX Oracle plugins into the data visualization tools within Oracle, calling a lot of the other things which I'm not aware of because I'm not really in that spatial space, the other Python libraries, third-party Python libraries to deal with spatial functionality, integrating that with Oracle's fantastic spatial functionality in the database as well. Sorry, I was excited by that. I'll step back. So PL SQL collections and records, we're kind of fleshing out all the support here. index by tables and records. Again, we're using the sort of get type functionality. Sorry, you have to be on 12.1. Who's not on 12 database? Sorry to be negative. I know you don't want to admit your company hasn't quite got you to that stage yet, but is anybody still using like an 11 or a 10 or something like that? Some, obviously, I mean, a lot of people are using multiple ones. But so everybody's on 12.2.0.1 latest patch set security level. Okay, I take that as a given. Or you're using cloud with 18C, right? So we're gradually adding all this functionality into the drivers as it comes out from the database. So here we have a user-defined type, UDT, so this is just something we've created. It's a procedure which has an index by table. We would need to pass that in, or pass that out, sorry, as a parameter. So call proc, people not familiar with Python, nobody was admitting before, call proc on line 3 just calls a procedure, and we bind in using that fantastic random comma syntax of Python. It's probably not true to say that, but that comma is there for a reason. We pass in the value there, and then we can iterate over that object when it comes out. So we now have an object, and we can just iterate and print out the data values. Sorry, I should have printed that out before. And if you want to print out the as list is just converts a representation to the Python list. So then you can use it in Python as any normal list. So I know some talks today have been pure marketing. Some talks today have been pure demonstrations. So I'm trying to fit somewhere in the middle. Hopefully, giving you a little taste and actually understanding what's going on without you watching me fail as demos fail. Binding PL SQL records, very similar. This is the setup again, the PL SQL side. We have a package, we've got our user type, which is a record in this case, and we're going to pass it in and out. And there's the method down the bottom, does some magic, just slideware examples of modifying the data just so we can see what's going on. So in Python code, again, you use this get type, kind of works everywhere. New object, we saw that before, no surprises. And then we just set those attributes. So that object now has these attributes which correspond to the attributes that we created in the PL SQL side, in the database side. We just set those directly and pass them in, and then in this case pass them back out again as well, and they get changed on the way out according to that procedure which I couldn't fit. If we had duplicates projectors, I'd be able to show you before and after. Trust me. Okay, implicit results. So implicit results are a way of getting query result sets out of the database without you having to do any of that binding. They're very easy to use in any sense. You don't have to pass them as parameters. There's a special syntax I'll show you on the next slide. And then there's obviously a piece of Python. Whoops. See what's happened there. Sorry. And piece of Python to get the results out. So here I'm calling it an anonymous block, so I'm not using a store procedure, but you understand it's the same. And there's a new DBMS SQL package, and I can just return the results. I'm returning the result of that cursor, that query handle, back into the Python land, and then that get implicit results call on line 14 just iterates over each of those SQL statements. And then I'm going to get printed out at the bottom. In fact, that's probably be one block of output because it's all one print loop down at the bottom. But I'm going to get results from each of those queries. And those queries, as you can see, they have different shape, different numbers of columns, things like that. So, scrollable cursors. Does anybody use scrollable cursors in any sense? We had a lot of interest in this when we talked about it at the big Oracle Open World conference. So cursors, as you know, the query result sets, you select data, get more data. And then if you, in your application, need to buffer it, you've got to buffer it so you can go backwards when somebody decides they want to page backwards or something like that. Scrollable cursors are a way where Oracle does that buffering for you. They're still buffering. Somebody still has to allocate the memory and hold it around until you decided you're finished with it, but we do that for you. So there are pros and cons to that. Use it as you will. And where have I flipped to? I've got to, okay, that way. Did I hit the wrong button? Sorry about that. So when you're creating the cursor in CX Oracle, as we saw, the cursor method just gives you the handle that we're going to use to execute statements. You just set this new scrollable attribute to true, and then there's a scrollable parameter afterwards. So a few examples here, probably too many examples, but you can see scrollable equals true at the top, and just execute the query. And then I have various modes that I can send in to say which record do I want back from that data set. Do I want the last one? Do I want the first one? Do I want to go to a particular absolute position? Number, go backwards with a -4 if you look down at the bottom on the line 11. And if you're following along and you remember from the data set, then effectively we're just going backwards and forwards across the row, last row, first row. So it's kind of handy. Is that something you would use in apps?
Sure.
Yeah? Use it, love it, sell it, good. Okay, AQ. Another really big, interesting topic, and I met with our advanced queuing team last week. Was it just last week? Which time zone am I in? They're fired up to extend their functionality even more and expose even more through all of the database driver access layers. But there's some pretty good stuff here already. So anybody doing microservices? AQ has a sort of role there you could use there. It's a queuing, producer-consumer. You put something in a queue, you pull something out from a queue, and Oracle has a lot of functionality I'm not going into about when you get the first one out, where the messages stay in after you pull them out so other people can look at them, expiry times, error handling, things like that. But from the Python point of view, which is what we're here to talk about today, and to set it up, we're going to create an object, we're going to be passing this object backwards and forwards. You create the queue, so we're calling some PL SQL, obviously nothing to do with Python there at that stage. Create a queue, so this is set up in the database, and there's queues across racks and all sorts of things. And we start that queue, we actually run the queue. So in CX Oracle, use our magic get type. We've seen that before. What is that type? What does it look like in the database point of view? And then we need to set some on-queue options and message properties. And I do have an example of that later. But on-queue options include those things I mentioned, like whether to buffer messages, whether commit needs to occur, things like that. Attributes include things like the number of attempts and delays and expiration policies and things like that. So we create a book, create a new object of that type, UDT book type, stick some data in, your favorite books this year, and then we can just call this on-queue function down there in red, con on-queue. Now this may change if we start adding things like array AQ and things like that. We may need to change this API a little bit, but you'll find that when you come to it. This one will still be around to use. So messages have been sent off into the ether. We have a little bit of print debug statement there. And then the other end, somebody else, somewhere else, another process, another one of microservices, something like that, can be listening for those. So they also need to know what a UDT book looks like. They set up their options, and this is where I set some of those options. Get the first message, don't wait if there is nothing to listen to, don't hang and don't block, just return an empty. And we just dequeue, we just loop and pull out those books, and obviously, as you know, we're going to get the same books back out. Some of this is like easy, you could just do this in your sleep, and we try and make this easy for you. If you look at AQ, there are lots of options. We try and abstract that into the database access layers. And it's important for you to tell us which bits to abstract. So, make sure you have a dialogue with us. We're out there on GitHub and places like that. I've got cards if you want to send me email about the things you are doing, what you're trying to do, where you're trying to take your businesses. Come and have a discussion with us about the things that you need in these languages. So CX Oracle 5.3 had a whole bunch of other stuff. I mentioned implicit result sets. Edition-based redefinition, people know that for being able to have multiple versions of PL SQL blocks in the database at the same time, and at runtime decide which one of those blocks to use with the same signatures. Worth looking up. Transaction guard, I'm sorry I didn't get through. Lets you verify the success or failure of a commit if there was a failure in the middle. so people don't have to have duplicate commits, and you don't withdraw money twice in a bank account and things like that. So you get a kind of something they call a logical transaction ID, and you can call back to the database and say, hey, have you seen this before? Did it actually make it to the database or not? Obviously, when things have recovered, then you call back. Yeah, statement caching, lifetimes, yep, greater, better. Okay, CX Oracle 6. Okay, what do you don't know? So August 2017, so literally less than a year ago. But if you look at it, it seems to be fewer changes than in that 5.3 release, and I'll get into that in a minute. The big one is that Python wheels. So how did we do that? We refactored the code base underneath. And we introduced a layer which we call ODPIC, which we retrofitted to mean database programming interface. And that is a layer of C code. All these drivers, I kind of look after the C drivers. And we now use that ODPIC in the Node Oracle DB driver, in the Python CX Oracle driver. The third-party person who looks after the Ruby OCI 8 has also got a second implementation coming along using ODPIC. There's a Go implementation, there's a Haskell implementation, all based on this ODPIC. So we kind of targeted it at driver layers. The important thing, of course, is that the CX Oracle API hasn't changed. So we've stuck in there, if you look at the diagram at the bottom, really just stuck in that little extra one layer of ODPIC, and you don't need to know about that. You're just calling down from the top. So a little bit of sidebar here. It's really, this layer is really aimed at database driver maintainers, but it is out there on GitHub, open source. You can use it if you want, if you're writing C applications. Feel free to get into it. The kind of key install things that it does is that it compiles without needing any Oracle header files or anything like that. So it kind of makes it easy to deploy and distribute. And because it uses DLOpen at runtime, for those who know what that is, it dynamically looks for Oracle libraries. It doesn't need to have knowledge of those compiled into it. So one binary, in this case one Python binary, that you install can run with different versions of Oracle client libraries. So if you install different instant clients, it'll pick up whatever you've got in your library search path. And that's the key trick. That for Oracle wheels, we now distribute one wheel, and it works with whichever version of the Oracle client library, 11.2 onwards, that you have installed. So that's the major thing there. Because of that DLOpen, you now do need to set your library search path. There's no way around that. You have to set that. There was a little trick there in 5.3, and some platforms we were able to automatically do some lookups. Sorry, that's not possible with this change, but the benefit of being able to give you wheels outweighs that. So just apologies for those people. So you could just run this Python -m install, and away you go. Okay, so sharded DB support. Who's using RAC, application clustering? Who's using sharded databases? Latest, greatest. So we now have sharded databases. Data can be split across multiple instances, and Oracle handles that. So at the end of last year, we added the API into CX Oracle to support that better. And what else do we want? Temporary LOBs. So if you're passing LOBs into PL SQL, binding them in, how do you create that LOB to be able to pass it in? We now have support for temporary LOBs. And a few tweaks. Last one I see, somebody was asking questions. Somebody got involved with the project, was saying, hey, we couldn't do this with a particular code block. We needed to support the DBI standard. So Anthony's added extra support in there for closing the connection when the context context manager is used. Okay, advanced tips and tricks. I've got a few minutes to go and lots of slides. Let's see how we go. I spoke about round trips, trying to reduce traffic between CX Oracle and the database, minimize that. Array size is the way you do that for queries. So you may have seen this in SQL+. Anybody still using SQL+? You may still see that, and obviously lots of other tools do things. They either call it prefetching or they call it array fetching. It's effectively the same thing. There's some batching of data comes across whenever you say, give me one row. Some layer may actually send back 10 rows and cache it until you need the second or the third rows and things like that. So you're optimizing your network traffics. Bind variables, I hassled you about before. Do I need to hassle you about that again? Do I need to get the whip out? Use bind variables. Do not use string concatenation to build up SQL statements, except in very well-defined cases where maybe you have your own hard-coded SQL and you're hard-coding your own hard-coded SQL together. Don't take SQL from users and hard-code it. Don't take data values from users and hard-code that in. Execute many, spoke about that before. Tick, you've got that in your tool list now, toolbox now. Session pooling, I don't have any particular slides on, but that's certainly a big win. So you want to set up a pool of connections in CX Oracle, available for fast use, especially if you're doing like a microservice where people are hammering your service. You don't want to be going to the database, create a connection, wait for the process to start up, use it, finish with it, wait for the process to die. You want that pool of connections ready to go so that you can be doing 10 things at a time, if your pool is 10 connections big. And if you're running mid-tiers, Python on multiple mid-tiers, or PHP, Python, any of these languages, JDBC, you can also set up a kind of pooling in the database called database resident connection pooling, and that lets the database side resources be shared across whoever's using them at that particular time. That has some advantages there. So I don't have any other particular slides on that. This is just a general tip and trick. Take it, look it up, ask me questions later. Okay, so real big tips. Subclassing connections, and you can do this with cursors as well. So we have some base classes there, Oracle, CX Oracle connection, CX Oracle cursor, and then you can subvert Python to do your utmost desire. So in this case, we are creating a new class, which is based on that superclass, the pre-supply class. And if you look down there on line 5, we're calling back to that superclass, the parent class. But this time we're passing in the database service name. Anthony chose that a long time back, but basically your connection string to the database. And so we're basically hard coding which database this application can connect to. And kind of extending that, then we can also have a cursor class, our own cursor class, and this effectively traps any call that the user is doing for the execute, extending that. So if you look down there at the bottom, line 17, you can see again we're calling the super cursor class to do the execute, but by the time it's got there, we've actually printed out some trace information. So depending on what was passed in, of course, this may be printing out. There was a connect from line 4, the top of the blue box maps to the line 4 where we do the print. And then we will do some kind of iteration of all of the bind variables. So if you want to see all of the bind values which are being sent to the database and hack your systems and expose it to hackers, do this. So it has pros and cons, obviously. I'm not suggesting you do that, but this is the way a lot of people do want to know what's going on in their applications. And you can obviously do a whole bunch of more interesting things as well, like logging and things like that, by doing other executes there in your new subclass. Row factory functions. Okay. So when you do a query, you're going to get a tuple back, and you can actually manipulate that before it gets back into your application layer with a row factory. I'm going to just show a simple example, which is the column mapping, but you may actually want to return custom objects. That's kind of probably more interesting in the real application. So here is an example of a row factory. We've got a cursor, we're doing an execute. We're using this standard Python collections package, and just renaming the tuples. So if you look down there on line 7, we're actually using those new names: new parent ID, new description ID, and we're just able to access that object, those attributes of that object, as if it was natural, which is what Python's all about. Obviously, you're going to get back the data that you passed in. So you get equivalent output if you weren't using that row factory and you were just doing these for loops. So down there on 10, just a straight loop over the rows, iterating over the rows, and printing out the IDs and descriptions. Okay, output type handlers. So that one changed the objects. This one changes the things like the data values themselves. So set an output type handler. the key one I want to get to in a few minutes is this returning the LOBs as strings and blobs as bytes. So let's start with a number of strings example first. So this is without it. This is the before scene. So you're getting number. If you look carefully at the 1 and 2 in the blue box, they are numbers. There's no quotes around the integral values. If I add a output type handler, so here at line 4, my new output line handler, output type handler, apologies. And I'm just saying that if the type is number, then we're just going to return a string of a certain size. Set it up so CX Oracle knows about it on line 8. Set the output type handler. And then when I do my query, same query as before, lines 9 and 1 are exactly the same. And I have the output type handler in it. And if you look magically, there are quotes around the 1 and the 2. So I've converted that to numbers. And this is kind of useful. I think I had to cut out the example with decimal, but you can do things like use Python's decimal converter and things like that, which are kind of neat if you have issues with number conversions between Oracle's decimal format and the binary format in Python, or you want to handle really large values. You can use exactly this technique to handle that mapping to your desire. But the example I wanted to show now is LOBs as strings. And you set output type handler. Here again, I'm just saying if the input type is going to be, this is on line 2, the input type of the data is a clob, let me actually handle it as a long. The same with the blobs. So the type is a blob, let's handle it as a long binary. Line 7, set that output type handler. And when I now query, this is your clob data. So people who have used CX Oracle with LOBs will know that they would traditionally have to do something like a value.read, do a read method on the return value to actually read the long value. What that means is that read is another round trip to the database. So the query is a round trip, give me what we call a lob locator back, just a pointer, and then I have to go and read from that pointer. And that's great if you're streaming large volumes of data, if you're doing media streaming and things like that, that's exactly what you want. But if you're in the megabyte size, a little bit bigger than those 32K varchars we're now at, you'll find that this is a lot faster than having to do that second round trip. So definitely recommend that. If you insert a string, you generally don't need to worry about doing anything magic. You just pass the string in and insert it, bind the string, your big lob string into a lob type in the database. Or you can use the cursor set input sizes. And I'm sorry I don't have an example of that. But there are samples in the GitHub repository. There's some samples there which do show how to use that. Okay, this shows converting an Oracle object to an arbitrary Python object. So what do we have here? We have a new method. I'm not showing you the building object, which you can see there on line 2. Just assume that there's something in Python, whatever creates this new building object. But we're going to pass in the Oracle object, and you can see there I'm doing Oracle object.building ID. So those are the object types as we've seen before from that get type call. We now set the output handler to use that new converter. So when we do our select down there on line 11, we're getting back the Python objects. So although we could work with the Oracle objects, the object Oracle object.building ID, we could do that. We don't have to do that. We can work with our own custom objects, extend them, whatever we like in the Python landscape. Input type handlers, the other way around. So, a lot of magic here, because we do it for you. You set a new attribute input type handler. You can either set these on the cursors or the connections, depending whether the scope, whether you want it applied to everything in that application or just a particular execution on the cursor. Let's start at the bottom. So lines 14 and 16, yep, you're seeing it correct, that's all that's up there. So we have a mythical building object being created, your Python object being created, and this is what we want. We want to just be able to bind this in line 16, that new Python object, bind that into the database and send it in. That's the goal. We know this is a Python object, and Oracle doesn't handle that directly. So let's have a new mapping, and I'm sorry, for slideware purposes, I don't show you the get type call, but we do a get type, and so that then this now converts the Python types into an Oracle object type. So we're assigning each of those Python object values on the right-hand side into the Oracle, Python, obviously Python representation of the Oracle object on the left-hand side. So Oracle equals Python. We set up an input handler, magic, basically saying that we're returning an object and we're going to use a particular input converter there in the red, and it works. Okay, so I'm kind of winding up. I think we've got about 4 minutes left or something like that. So just a quick summary, over the last year we had a huge number of new features pushed into Python CX Oracle, so I do recommend you update with that pip install upgrade CX Oracle. Do recommend you update Oracle Database, but don't forget Oracle Database and Client have this what we call client-server interoperability. So you can be using version 12.2 client and talk to an 11.2 database, or I forget where that goes back. There's an official supported version, and there's an actually works, which is even greater. So you can go back even further and the other way around. So you can at least upgrade your Oracle client version, and there are some advantages to that in terms of things like the session pool management and dead session detection and things like that. So at least upgrade your Oracle client if you can. And hopefully you'll be able to take advantage of some of these new features and make sure your applications really fly. So we've had PyPy, we've got RPMs, we've got improved testing. I didn't mention I really should give a shout out to our testers. Once the project came in under Oracle's umbrella, we have testing at the ODPI level, we have testing at the Python level, we have functional testing. There's a lot more going on there. So I think things are getting we're finding a lot of little edge cases and quirks and things like that that are being fixed as we speak. So CX Oracle, long history, it's been around for a very long time. Extremely popular, it's our most popular of the open source drivers, about 2 to 1. So at various times, the flavors of the month and holidays, whatever, but you can get 100,000 downloads a month of the driver. Oops, another cloud mention. Have you heard about Oracle Cloud? Has anybody ever mentioned Oracle Cloud to you? Yeah, okay. Thanks. And we now use this Oracle abstraction layer. And just in the wrap-up slides, we do have a new series of office hours for a lot of technologies here in Oracle. And there's a Python office hours comes up, which as you carefully will notice is only half an hour. And I know your developers, who wants to sit around for an hour, so we just schedule it for half an hour. Turn up, don't even have to be there at the start. You can, it's a video call, you can dial in if you want, chat, whatever works for you, ask questions. We try and have a theme each month, so next month we are going to talk about the execute many. So we'll have a few slides on that, and then we'll just sort of hang around. If there are no questions, we'll probably drop off. But I do recommend it's a way to start this dialogue with us and come and learn a little bit more, perhaps in depth about each of these features. And obviously, when you have your favorite topic, you could say, hey, next month, can you talk about X? We can talk about X. And this is it. That's the wrap up. That is me. There's a Facebook group there which doesn't have a lot in it except me posting the equivalent of what I post to Twitter. But I know in some regions of the world people don't use a lot of Twitter, so I just push that out there as a group, so you can join it if you want. But there's a lot of places you can get resources and can get help. And we're working with our doc team to make sure we can produce some proper user documentation as well at some stage, rather than just the API documentation that's out there. So, appreciate your time today. Thank you very much for coming along. Hope you enjoy Oracle Code. And if you have any questions, please do come and ask me after the session. I'll be talking at 5 o'clock on Node.js in one of these other rooms. Also, I'd be happy to see you there as well. Thank you very much. Oh, if you want questions, yeah, you can shout them out, or you can come up and ask questions if you want. Because I can't quite hear with the background, so maybe. Yeah. Speak loudly, that's better.
Better?
Yeah.
Okay. So I was wondering, with the Python wheel, is it at all possible to package the libraries that are necessary?
Okay. So this is a standard Oracle question, which is, in some senses, my responsibility because I own those instant client packages. I mean, there's a lot of technologies under them from various different groups that contribute to it, but I kind of get the responsibility for chasing it. There are licensing issues because there are third-party licenses in there we have to satisfy. There are business reasons, so we have to go through our legal group, we have to go through our business groups to try and get approval for that. And then the big one, we wouldn't do it in the wheels, perhaps, is like there are, well, maybe actually with wheels, but some languages we may not do it because we wouldn't know which platform was actually being deployed on at that runtime. So wheels we could do, yeah, I do know that. But it's a known issue. We'd like to help you. Had meetings even last week on this stuff, ongoing issue, but it's a big company issue. You know, a lot of really important technology in there, like the encryption support and things like that. So the other question which comes up is why don't we just get rid of that and write a native driver which talks to Oracle database? We'd have to do that for every single language. We'd have to support it. How would we do the encryption levels? That's a big effort. So there are pros and cons to this. You get a lot of features just for that little bit of pain when you actually have to do the install. But I do appreciate that.
People might install the wheel, but then they'll install the wrong version of the Oracle Instant Client library, like different, 32 bits and 64 bits.
Yep. So we've done some work there in the messaging, error messages, so we'll now tell you which one you're missing. I've got plans. Remember that slide which says don't make any purchasing decisions? I would love to have easier installs, perhaps MSIs on Windows, which included the Windows redistributables, which is the big problem in Windows. And anybody who knows me, I worked at a Linux group, and if you've seen there's Bob Rubart doing interviews at the other side of the hall. The last one I did with him was why you shouldn't use Windows. All these open source things actually do turn out to be a little easier on Linux. It's just the way it is. But we'll try and make things easier for you as we can on Windows, and certainly having pre-built binaries and wheels and things I think is the next stage. We've gone there. Node, we've suddenly caught up and done that as well. So. Thank you. Any more questions? Yes, one more question.
I was wondering if you have any performance tuning tools that you like out there
Performance, did you say? Performance tooling.
you guys like?
I don't actually know for the Python side, to be honest. There's a huge range out there. For the database side, we always try and encourage your DBAs to speak to your developers, because there are things like AWR, all those sort of.
I'm on the DBA side. So.
There you go. So it's your fault. Because that's actually not. I mean, there's often a big divide between DBAs and developers, but there's a lot of tooling in the database, like the AWR reports will tell you, oh, you've connected too many times, you should be using session port. Oh, the statement's being parsed too many times. Oh, you should be doing binds instead of string concatenation. So in that side, the AWR, the automatic workload repository, and the ADDM tools,
I already use those.
perfect. So those are the ones I recommend the Oracle. If it's got Oracle on it, I recommend it. Okay, thank you very much. That's it, we should wrap up. Thank you.